Hello, welcome back. This is Software Sundays. I am KD. I'm a software engineer, a technology architect, and all-around tech enthusiast. And in this show, Software Sundays, we go over the latest news inside of big tech, any late developments for engineering and how we're building software, and we discuss a few topics that can make us better engineers as we grow in our careers as individual contributors and even as engineers and technical founders building innovative products. So with that being said, let's get started. So starting off, we're going to talk about a story with Anthropic, which is now valued in the range of $350 billion following an investment from Microsoft and NVIDIA. This is another story inside of the AI bubble talk, which may not be a bubble. We'll talk a little bit more about that later on. But this is another example of more investments into AI infrastructure, or from AI infrastructure companies into this new generative AI platform as a technology. It makes me think about the fact that at the highest levels, these companies are hedging their bets against disaster by not investing only on a single side of the field. They are continuing to invest significantly in different players and not thinking about it as a competition, although they are all very competitive. But they are all investing in a way to see, how do I make sure that my investment is actually successful given the uncertainty in the space. We're not sure which of these companies are going to last. But you can see Microsoft was one of the largest investors inside of OpenAI when they were initially starting up. And now they're investing in Anthropic, which is them kind of being aware that they're not sure if I'm not saying they're doubting the fact that OpenAI will be here, but there is something to be said from the fact that they feel very strongly enough to make this investment that Anthropic has a space inside of the field as we move forward. I think Microsoft is still one of not the majority owner of OpenAI, but they have a significant ownership stake inside of the company. So there's something in there that they're not just waiting to see how OpenAI does. They're actively making other investments inside of the space to make sure that, they know that return is going to be there. And even with Anthropic, it's, some people would talk about playing both sides. In 2023, February, GCP was their main partner for training, deploying, and running and scaling their models. By the end of the year, AWS was announced to be their key strategic partner for training as well as mission critical workloads. And today we're seeing them considering the next level of their scale, the next level of their growth as they train their models is going to be built entirely on Azure resources, which are going to be powered by NVIDIA chips. And it's not like NVIDIA chips are not accessible in AWS or in GCP. All of these hyperscalers are purchasing those same chips. So there's something inside of this new relationship and this new partnership that is worth cutting. And that's very interesting. It's something worth keeping in mind as we move into the future. And it's a lesson. You don't just wait for that, that risk or that bet that you put in to just materialize. You have to always be keeping an eye on the field, because 2 years later, something else may look like an attractive opportunity. And I'm saying look like an attractive opportunity. I'm sure there's no guarantee, but there is a possibility that's worth keeping in mind at any stage that you are in business, in life. You have to be flexible enough to be able to keep your eye on the ball that is the main ball, but also be aware that there are other things happening in the environment that may change something for you. Next up, we're going to talk a bit about the newest outage in the internet, and that was caused by Cloudflare this time. So we're seeing significant disruptions in key internet infrastructure. And it could be a coincidence that, and just a few weeks ago, we saw a disruption from AWS. Today or this week, we saw not a similar effect in some different services, but having a similar level of scale in the fact that there were a number of applications that were no longer available because of this outage. And it's reminding me of like the 20th century, late 20th century to early 21st century, where the usage of electricity and the power grids, that growing usage and the number of people using electrical products and services caused a lot of strain on the existing infrastructure of the time. And that existing infrastructure was not able to keep up with the growth and the demand. And so we actually experienced a number of different blackouts in the 1990s, early 2000s, that were significant and affected millions of people at the time and caused significant damages. Almost the outages themselves did not cause any damage in most cases, but the breakdown of these systems that people rely on can have negative effects. And so I don't know if the clustering of these outages is due to just the growth of people on the internet and the fact that, everyone and their mother is moving onto the technology field. Or could it be an after effect of high employee turnover due to mass layoffs, maybe an increase in deployments using AI and in untested environments? Or is the system just unstable? I'm not exactly sure what the answer is, but it will be interesting to see what are the changes that take place. Because it's very clear how reliant our system, our society is on these services and these platforms. And I'm wondering if that creates an opportunity for more regulation. And honestly, I'm sure there are a number of regulations that already exist due to the security, privacy, data aspect of these of these systems, but I'm not sure if we start seeing a number of other requirements required to release software. And does that make it more difficult to add changes to the network and to the system? Or do we just keep going as we are today and, if it break fast, fix fast? And I'm not sure. But that is something that I'm keeping an eye on, because it's not like you just give up on Cloudflare now, right? The service that it provides as a company is still needed. It's still necessary. They still are going to be a key player inside of the scaling of the internet. But with them having such a significant role, I just wonder if we need better guardrails in place. And I'm not necessarily advocating for more regulation. I'm just wondering what changes. Because when we started seeing how challenging it was to grow on the old power grid, we started seeing more rules coming into place to make sure that that reliability could be maintained. But with that regulation, and increased regulation, does come in, I won't say an end, but it significantly disrupts growth and the acceleration of growth. So it's something to keep in mind. And as we're thinking about growth and the future, I also saw an interesting story from Balcony, which is a blockchain Web3 platform that is they are actively innovating inside of the real estate industry to accelerate the transition from manual, centralized systems to a more efficient system with smart contracts, tokenization, and the like on blockchains. And Bergen County in New Jersey has signed a 5-year agreement with Balcony to digitize 370,000 property deeds and put them on chain. That represents billions of dollars worth of real estate that is now going to be tracked, accessible, and owned, if anyone can own the blockchain, on the blockchain. And it's I won't say the first peek into what real world tokenization is really going to look like. Real world asset tokenization is really going to look like as we move forward into the future. But this is a interesting use case, because one of the reasons that you might even need or want to tokenize some of these deeds is to move the risk of having all of that data owned by one central authority, being the Bergen County government. The number of local agencies and government offices that have received ransomware attacks has been growing in the recent era. The cost of these attacks are starting to grow in amounts too. And so it's becoming more of a risk for the government to hold on to this data, while it also being of greater importance that you cannot lose access to your deeds or to the ownership record of the property inside of whether it's a city, your state, your county, your country, you cannot lose that type of data. And I mentioned a few months, maybe a few weeks ago, the organization CISA, I think the Center for Internet Security Association, or some type of government office that was responsible for accelerating the transition or the adoption of best practices or security best practices for government and state agencies. And they're having their own cutbacks in funding and their amount of resources available to help support. So we're seeing greater security risks. At the same time, we're seeing less resources available to protect against those risks, while at the same time, the assets are becoming more and more valuable. And so moving things into the blockchain can make it so that there's no longer a single target in the event of some type of ransomware attack. It's not like you can take down my computer here and all of the other computers that exist in the world, or all of the other computers that make up the nodes of that blockchain. Not to say it's impossible, but it's a more significant attack, and it requires significantly more resources that are more difficult to actually pull together. So there's a level of increased security by going into the blockchain. And it being the possibility and potential of adding smart contracts into the real estate infrastructure, and the real estate transaction infrastructure, could make even more opportunities for efficiency. Because now, instead of having to require all of the checks that you and administration costs that you would need to do with a physical record, if it's digitized, you can have something like AI or some type of automated system that can do some of the extra checks that need to be done. And that might just make, I won't say it'll make real estate cheaper, but it might make the transaction costs a bit cheaper and just add more efficiency into the process. I think it's also important to highlight that the blockchain that they're choosing to use and put these assets into is Avalanche. And it's not, I won't say it's not well known. Unless you're in the crypto space, you may not be aware of what Avalanche is or what their chain represents. But it is a layer 1 chain, or blockchain, that is super fast, significantly faster than Ethereum and the Bitcoin network. And it has native smart contract accessibility. And so they don't have a significant amount of assets at this point, but I think Avalanche as a chain may be worth keeping an eye on in the future, depending on what else moves into that chain and what other real estate assets go over there. And following up on our AI story is the fact that NVIDIA has continued to see growth in earnings, which shows a sustained investment in AI in the space. So we're not seeing any levels where they're not being able to sustain their current investments at least NVIDIA specifically. The CEO still says that software, even non-AI software, for data processing and other kinds of new apps that are being launched into the market still requires increased computing power. And that's still where NVIDIA shines, where their GPUs shine. So the message there is that whether it's AI or data lakes or not virtualization, but VR or AR, they're going to still be leaders inside of the technology space just because the technology that they provide, their chips, those semiconductors, are going to be required and necessary for every shift in the platform or for every layer of the platform as we move forward in technology. So that's basically saying that the demand for compute is not slowing down in the foreseeable future. So we may not know yet who is going to be the winner of the space and who's going to last into the future, but we do have some faith, if you want to call it that NVIDIA will be part of that team that makes it to the other side. And even thinking about the fact that Gen AI, generative AI, the AI that powers ChatGPT and text generation, that space is still growing, but even when it is no longer growing, it'll still exist. We're not going to give up on the technology, even if it doesn't give the same return as people are expecting, at least over the short term. All right, so let's get into some of our questions from the audience.
What is the cloud?
So the cloud is a computer or a lot of computers that exist inside of a warehouse thousands of miles away from us. And that's for some people. In some cases, you might be living in Virginia and the cloud, the data center, is maybe a few dozen miles away from you. And it's basically a computer that you can access via the internet. And that originally, in the legacy model, was usually on-prem. On-prem meaning the company that provided the service, whether it's a bank, a retail restaurant, or a supermarket, or any other entity that was using the internet or providing services on the internet, they would manage their own computers. And those computers would be in the basement or in some type of closet nearby. And anytime they wanted some data from that computer or they wanted to make a change, they had to update or access that computer directly. The cloud was a novel shift inside of the platform that I think one of the original providers that revolutionized the service was AWS. And now we do have a number of competitors such as Azure, Google Cloud, and some other small players. But they changed the model from having to invest heavily in CapEx, which means having to invest, when you're a new company, having to spend thousands of dollars and months of effort and time setting up a data center. So that means setting up computer servers and racks, networking those racks, and even ensuring that there was power lines that were getting to them, setting up backup generators just in case of an outage, and even setting up the networking for not just internally inside of your building, but also making sure there was reliable internet connectivity to the rest of the world. Originally, a new company would have to do that type of, they would own that layer themselves. And again, that was really costly, and it made it difficult for new companies to innovate, because every change inside of your platform or inside of your service, your technology, would require a significant shift or a significant redo of your actual computing infrastructure. With the cloud, you no longer have to think about, do I have enough capacity to test this new product or service? You can actually test it and deploy that product into the cloud, into these remote data centers or remote computers, and you can get feedback on your testing immediately. So that decreases the amount of time and effort required to introduce new services, while also reducing the upfront cost that it would take to just test something. And so the cloud was the solution to the fact that managing a data center is very hard. And it's not something many people have the skills to do. And so now with the cloud, you don't have to have that skill in-house. You can rely on the best in breed who can set all of that up for you.
When should I use AI as an engineer?
So AI can be brought in as a thought partner early inside of the process, or late to help uncover gaps inside of your thinking. When we're thinking about AI, we want to make sure, even as an engineer, as an individual, as a business owner, wherever you are, whoever you are, whatever you do, AI, whether it's ChatGPT, Gemini, or any other product you may choose to use, they are not capable of thinking for us, of thinking through an entire problem set for us and making decisions. There are certain decisions that they can make very easily, and then there are certain decisions that are outside of their scope, at least at the time being, or for the time being. And that doesn't mean that you can't use AI in some, important spaces. You can, but it requires you to make sure you as the operator of that system are clear about what your requirements are, what the limitations are of the tool, and clear about how you're going to test for any types of hallucinations. And I would say a hallucination could be anything. It's really just a mistake. We don't want to give AI the ownership of an entire process without any type of human intervention at this stage or at this phase of its development, because it's not built for every domain. So as an engineer, I use Cursor and ChatGPT while I'm coding and developing. Originally, I had used GitHub Copilot with my IDE, and the experience just wasn't to me. It would spit out a lot of code at once that I just was not capable of processing so quickly. So it was a lot faster than I was in terms of thinking and I'll say thinking and put that in quotes because it's going to give you something. It may not have thought as deeply as you're going to think about whatever the topic is or that piece of code. I ended up switching to ChatGPT, and that was like my standard development tool. I would be inside of my IDE and have the ChatGPT window open. I have a developer project which is loaded up with a specific prompt that says, we work on AWS projects. We use Golang, Flutter. These are my, this is the style of coding that I like, and those types of notes that would help my coding code pilot work with me. And then as I asked it prompts or asked it questions or gave it any type of errors that I was experiencing, I would copy and paste that code into my IDE and run it and test it to just see if it worked. Sometimes the generated code would be what I needed. Sometimes it would be too much, and sometimes it wouldn't be enough. And I would have to go back in and either update the code myself, or I would have to refine that initial prompt with ChatGPT. Today, I'm using Cursor more often to make sure that I don't have to have that same back and forth between the ChatGPT window and my IDE. I can ask Cursor to generate some boilerplate code, and because it has access to the rest of the code base, it is able to provide a good level of support and some really quick changes that are well defined and documented. For any types of new features or integrations that I add into my code base, I do avoid using AI, or I am learning that I should avoid using AI, especially because if you don't understand the thing that you want the AI to do, it'll do something anyway. And if you don't understand what it's doing, you're going to have a very difficult time testing its output the way you need to be doing, the way it needs to be tested. Again, they hallucinate. So try to keep AI usage into the realms and the tasks in your life that you are very used to doing, that you are so adept in, that you can quickly check whether something is right or wrong in your space or in your task. Because AI needs an operator that can say this was wrong, or an operator that can say this is right and this is how I need to fix it to make it even better. As a developer, I also use tools like Lovable. Well, I use Figma Make. I think I used Lovable once, or I've played around with some Lovable apps. And there are some other tools like Base 44, but any of these tools can help create a very quick proof of concept. It'll give you a beautiful UI that can have some interactive buttons and features on it, but it is not a production-ready application. You still need an engineer or developer who can take that and actually turn it into something that you can put in front of customers. But using these types of tools, it accelerates my timeline from idea to something to look at. And so it just makes the process faster. And that's all we're looking for with AI. We're looking for tools that can give us a faster feedback loop that we can iterate on more effectively. So that's when you use AI in your engineering.
What is the difference between front end and back end development?
So traditionally, the front end was everything you can see in your face as a user. That is the website that you go to, the app that you're clicking through, or the way that you actually interact with the software. And to you, it doesn't even feel like software. It feels like a menu. It feels like uh, a website or something like that. It should feel very natural. That was the entire uh, thought process behind of the front end. It's built to create a user experience that is intuitive and frictionless. And so it helps make things easier for you that you can touch and hear and see. On the back end is what powers the magic that you expect on the front end. The back end is the functionality that makes sure when you press transfer, someone is notified in case that was fraud, that something is being done to actually move money from one account in this bank to another account in another bank. It is the functionality that stores that transaction for, tax purposes, for your purposes, for just as a provider or institution, making sure you have some type of history of what is happening with your platform and with your customers. The back end is all of that. It's the security. And so when we're thinking about the front end and back end for development, they both are designed to create an experience, to create a product or service that a user can rely on. And you can change the front end, you can change the back end, and it'll change the entire experience. The benefits of separating the front end and the back end is the fact that we can say, I want to change something, or I want to keep everything inside of the user experience the same from the front end. I want to make sure the buttons are familiar. I want to make sure that the flow is familiar as you move through the app to do certain things. But I want to make sure new things happen in the back end. So in the past, whenever a transaction went through and you click transfer on the front end, in the back end, that transaction could have literally been given to it could have been emailed to some type of analyst. And that analyst would maybe look through your previous transactions and, some other things to see whether or not that was fraud. And this was all done through email without you knowing what was happening in the background. Now, they want to update this backend system to say, all right, we're no longer going to need an analyst to look at it. We're going to create another service or another application that can review those reports faster and more efficiently and more accurately. And you might use some type of machine learning model that can create a score for the probability of whether or not this is fraud or not, using different data points from you personally and just from the market in general. But in the front end doesn't need to know the difference between either process 1 or process 2. All you as a user need to know is when I pressed transfer or when I made this purchase, it went through. Or if it was really fraud, it did not go through. So the front end can allow you to, having a difference between the front end and the back end allows you to make changes to either side without having to affect the other side. And so sometimes it might be you want to change a button to make it look different. But in the back end, it's all exactly the same. The button that you change is just supposed to help make it more intuitive to your user or look better to your user. And you can only do that by separating these two aspects thoroughly.
How do I move my apps into production?
So for many apps, it does depend. If you're thinking about a web app, production it's accessible on the internet. For a mobile app, like Instagram, or Instagram does have a website, but on your phone, if you're accessing it through the App Store, whether it's iOS or Android, that requires a different deployment process. And it also depends on the framework or tools you're using to build that application. If I was just building a web app that only needed to ever be on the web, 10 years ago, I might just use at that point, they were using like Angular, Vue, those types of JavaScript frameworks, or front-end frameworks. 20 years before that, it's probably, I'm trying to see if we even had HTML back then. Let's say 1999 to 2008. You're using pure HTML, CSS, and low JavaScript to send your message. That deployment process is going to look totally different than the process that we'd expect now. Because back then, you were just bundling a static files and making them accessible. Now, we're usually building or packaging our output, packaging the web page into some type of executable. And for the App Store example, you're giving that executable to Apple, and for example, and they're going to make that executable accessible through their App Store. And it runs very specifically on their devices in a certain way, and they own that entire process. All you have to do is create it and give it to them, and they handle the actual deployment or how to get it in front of a user. But that's, again, for just mobile native apps. If you're deploying to the web with something like Flutter, you can set up a server to deploy your app to. And when you deploy that app, it lives on that server, and your app is basically, you would build it first, which is just saying, I want to turn all of my code into something that can be displayed on a browser, whether it's a web browser, mobile browser, any browser, literally. It could be an Internet Explorer. It could be Chrome or Safari. How do it's making that code accessible to those clients. Clients when I say client, I'm referring to the browser. A browser is a client in this example. And whenever you go to the server, going back to how do we move it into production. I was describing what production would look like for the different sides, but in terms of the process, which is usually a dev op projects or process, with me right now for my Apple apps, I actually am doing the entire build and upload to Apple App Store. I'm doing that manually, and so I'm building it on my laptop. I am cleaning out. I'm cleaning the build folder. I'm building the executable with Flutter Run or Flutter Build. I'm doing. Taking that build and turning it into a package on Xcode, which with Xcode archive, and I'm uploading that archive into the App Store Connect platform. And then from App Store Connect platform, I can tell Apple, hey, release this to my users. And that's a very manual process that I'm doing right now for my app. There are a number of ways you can automate it. I just haven't gotten to that for my steps. But on the back end, that's for the Flutter native app. On my backend Golang application, I'm actually using GitHub Actions to package my code, which is turning my Go source code into a Go executable that can run on anything. And then I'm taking that executable and I'm putting it inside of a Docker image so that it can run with a virtualized and containerized environment. And then I'm taking that image that I created with my Go API, which is the executable code. I'm taking that image and I'm giving it to AWS. And I'm telling AWS to whenever, and I'm running it on an AWS Lambda instance, so serverless. So going back to the cloud, I'm running a computer. I'm giving a computer in AWS world my container that has my code and knows how to execute the code and do all the things it needs to do. I'm giving it to AWS, and there, whenever they get a request to my URL, they're going to run my app inside of that container. And that's all done serverless. I don't have to worry about what type of hardware my container is running on. I just know that they're going to run it whenever a request comes in. And so that deployment is all done through GitHub Actions. I've also worked with some tools like CodeFresh, and GitHub Actions, CodeFresh, these are all CI/CD tools, which basically mean they can create scripts to automate the different steps to get your app from source code to in production. And it really depends. What type of app? Is it a API? Is it built with Java? Is it built with React? Is it a web app, or is it a mobile app? Is it just a server API, or is it some type of maybe it's a library? Because production could also mean you're deploying some new library that you created into Flutter packages or inside of the Node package management space. So it really depends what your code is meant to do and who it's for, how you move it into production. Because production just means, how do I make it publicly accessible? Technically, with that definition, you could just share the source code. But again, going back to who is the target user, if your target user doesn't know how to turn source code into a running app on their phone, then GitHub as a target location is not production. So you have to make sure your production looks like where you want people to use it and access your application from.
What is the blockchain?
So the blockchain is I'm gonna give you like the high level definition. It's a distributed and immutable ledger that anyone can add blocks or transactions to. And those transactions or blocks can be verified by any person who has access to the ledger, which is, again, anyone or everyone. And there are some cryptographic protocols in place that ensure that no data on that chain has been manipulated by any party. And so I guess I wonder if the blockchain is really a technology that allows users to have more trust that the data that they're accessing is the right data that was placed there. So it's supposed to add transparency, and it's reliably stored, right? Because it's distributed. That means I have a copy of the data, Jack has a copy of the data, Lamont has a copy of the data. Because it's immutable, there is a way for me to test and check whether the data inside of the chain has been changed. And because anyone can own it and it cannot be manipulated, I guess that's the main focuses of distributed and immutable. But by having that distribution and that immutability, you can verify that whatever you put on the chain is not going to be changed, because just because I want to make a change inside of the data doesn't mean that Jack and Lamont made the change inside of the data. So I can check their copy of the data and say, hey, or someone who is trying to audit something that I did, that when I change my copy of the data, they can look at the other copies of the data and say, oh, something is wrong. And why would you believe Kevin's copy of the data when the entire world has a different copy of the data that they're saying is more accurate? So that's what we're talking about with the manipulation checks. And so a blockchain is owned by different nodes. See, Lamont has a node, Jack has a node, Kevin has a node, and anyone else can have a node. A node is just a computer that is running the blockchain software. And there are different types of blockchains. There's the Bitcoin blockchain, there's the Ethereum blockchain, there's Avalanche, I mentioned earlier, and I think Avalanche has like 3 different chains on their network that have different requirements, as well as different pros and cons. Blockchain can be used to mint NFTs or non-fungible tokens. A non-fungible token is the same as a real-world asset token, right? When we're talking about the deed that was saved onto a blockchain, that's just an NFT with a different name. Smart contracts. These are programmed, they're stored inside of the blockchain, but they're programmed off-chain to trust the blockchain's history. And so when something happens on the blockchain that they're monitoring, they're able to say, oh, this change happened, and this is what I'm supposed to do when that change happens, so let me execute that code, whatever that code may be. And they can also process cryptocurrency transactions. A block can store any type of data. It can store a transaction to say this amount of coins moved from Lamont to Jack, or it can say Jack put this piece of art onto the chain. And that transaction to the blockchain means nothing. Whatever the data it's storing, it doesn't matter what the data is. It knows it has data, and it is organized in blocks that are connected through pointers, basically. So I know the last block was XYZ, I'm ABC, and the next block will be element OP. However, whatever alphabet or number you choose to care about in that instance. And yeah, blockchains are kind of known from NFTs, cryptocurrencies, and Bitcoin. But the blockchain as a technology, as a platform, I don't even think we've gotten a taste of it with NFTs, right? Digital art. But we're going to start seeing decentralized finance, where everyone can have their own cryptocurrency, their own coin, that ideally is backed up by real assets. We're going to start seeing greater transparency because all data will be accessible to everyone. And yeah, I think prices will go down too, because now all of the institutions that we relied on for verifying and storing the data, they'll no longer be necessary. But you'll still need some type of validation and authority to say whose data are we. Because anyway, if anyone can add a chain, how do we say that the county of Bergen was the one that added this chain? Why Harry could have just added that he owned this deed or they owned this property? How do we know that that chain is not valid? Even because it could have been validated by the chain or by the blockchain, but there are other questions you have to consider. And those types of, but for the most part, the cost will either, I don't know if anything will ever go down, but it may not accelerate due to administration cost anymore. So it's an interesting platform and technology, and it is having major effects in the US, but also throughout the globe. There are countries that actually do transactions in Bitcoin. Think about that. They have a native currency, but instead of saying I'm going to pay for a piece of a pizza with $1, I'm going to pay for a piece of pizza with 1 Bitcoin or 1 Satoshi. And so we got a lot of road left ahead of us for these technologies and platforms and what they're going to do in the future. And so that was pretty much all we have for questions and news today. I hope this has been valuable. Some final thoughts that I had was, I saw a video recently where the guy, Alex Hormozy, he was talking about the fact that if people realized how difficult the goal, or how difficult it would be to accomplish the goals that they had, they wouldn't even attempt some of the challenges they end up going for. So it's basically saying your naivety is your greatest weapon against procrastination, in my opinion. Because you don't know how difficult it's going to be, you can go into the task and into the venture with some excitement. You can go in saying, "Oh, I know what the vision is. I know what I want to build. I know what I want to see. And because you don't realize how hard it's going to be, you're going to just start. When you spend too long thinking about all the what ifs and the how will this work, you start procrastinating. And yes, research is helpful. It can give some clarity into the process that you're jumping into to hopefully make sure you're not, doing something extremely foolish. But too much information doesn't necessarily make it a good thing. Having too much information can scare you away in some instances. If you knew how many miles it would take to become the best runner, and you had to look, and you looked at that from the place where you started, that would look, maybe running is not the best example here, but maybe a mountain. If you could see the top of the mountain, maybe you can't even see it. What if the top of the mountain is there? You just know it looks so far high up. That might make you turn around. But if you only see the part of the mountain that's in your view and it looks like, oh, it's high, but it's not so high that I won't be able to get there, then you'll start that journey. And then maybe when you get to that peak, you'll realize, hey, this was just the first peak inside of another peak. Maybe you don't know the entire story and all the peaks that you're going to hit. But seeing that goal clearly and not thinking about the other steps behind it can help you just move faster and accelerate your development. Because the entire time you're trying and you're working and you're building toward it, you're going to develop, you're going to get better, you're going to become the person that actually can reach that mountaintop that you're looking for. Now, when you started, you may not have been that person. It's okay. As long as you started. And because you started, you were the right person to get to the next step. So that's my message really here today. Sometimes all you need is a vision and the heart to keep going and overcoming the obstacles. And that's all you need to get started. So, don't think too much about it. Do what you can, do your best, and you're going to be great. Everyone, have a great week. I hope your efforts are fruitful this week. Only for positivity, though. If you got negative efforts, then I hope you fail miserably. Because haters don't prosper. My sis told me what she said. She said, a pretty girl ain't hating, and a hating girl ain't pretty. So never hate. It don't look good. Peace out.